astronomical, pedantic ways of explaining things.
Mysteries abound in the vastness of space, just waiting to be solved. And one of the universe's most puzzling mysteries was revealed in 2017. Oumuamua. When astronomers at Hawaii's Haleakala Observatory discovered this enigmatic interstellar object, it captivated the attention of people worldwide. Experts were baffled by its unusual form and its surprising course. It shattered every rule of thumb. Nothing like that had ever been seen by us before. Was that a comet? A space rock? Or maybe something completely different? However, just when we believed the tale was over, word leaked out of NASA's hallways regarding Oumuamua's imminent return. But how does this impact the human race? Is it a sign of impending disaster? A heavenly messenger bearing ominous news? Join us as we explore how NASA scientists warn Oumuamua is returning to Earth and the implications of its impending return. The first interstellar object to pass through our solar system was spotted by astronomers using the Pan-STARRS survey on October 19, 2017. The object, which has the designation 1I 2017 U1 Oumuamua, sparked heated controversy among scientists and continues to do so to this day. The fact that this object was detected showed that interstellar objects frequently enter our solar system, which was something everyone could agree on. And as time has passed, scientists have found that occasionally some of these objects hit Earth as meteorites. This begs the crucial question: have extraterrestrial bodies been visiting Earth for billions of years? If so, might they have carried the necessary components for life? Panspermia is the hypothesis that the universe is seeded with life and spreads via asteroids, comets, and other celestial bodies. In a recent study, a group of academics examined the consequences of interstellar objects being the cause of panspermia. Their findings suggest that interstellar objects may be able to provide the material for thousands, if not billions, of Earth-like planets to form in different parts of our galaxy. Junior David Cow of Thomas Jefferson High School for Science and Technology was in charge of the group. In a nutshell, panspermia is the belief that extraterrestrial objects bring life to Earth. Theoretically, these extraterrestrial beings evolved into extremophile microorganisms that could endure the extreme environments of space. Because of this mechanism, asteroids make their way through the interstellar medium and eventually impact planets that could support life. This distinguishes panspermia significantly from other rival theories of Earth's origins, also known as abiogenesis, the most popular of which is the RNA world hypothesis. In this theory, RNA evolved before DNA and proteins, which in turn led to the emergence of indigenous life on Earth. However, Cow argues that panspermia is not an easy phenomenon to evaluate. Panspermia is hard to evaluate since it incorporates so many variables, many of which are unknown or have no constraints. For example, we need to think about the biological aspects. Can extremophiles withstand supernova gamma radiation? The physical aspects of panspermia. How many objects impacted Earth before the first fossilized evidence of life? And so on. Moreover, there are still many unanswered or poorly modelable questions regarding these factors, such as how many extremophiles would actually reach Earth in the event of a collision with a life-bearing object, and what the likelihood is that life could originate from these alien extremophils. Our understanding of the plausibility of panspermia is continually changing due to these and many other reasons, such as the fluctuating star formation rate and the recent identification of many rogue free-floating planets. Panspermia is difficult to quantify. Being the first interstellar object to be detected, the 2017 discovery of Oumuamua marked a watershed moment in the history of astronomy. Interstellar objects probably pass through our solar system frequently, some of which are probably still here, and their detection proved that they were statistically significant in the universe. A second interstellar object, 2I Borisov, entered our solar system 2 years after the first one, but this time, its nature was not shrouded in mystery. The comet 2I Borisov developed a tail as it drew closer to Earth, confirming its identity. Subsequent research has shown that some of these objects become meteorites that impact on Earth's surface, and a few have even been identified. This includes Cineos 2014-01I08, a meteor that crashed into the Pacific Ocean in 2014 and was the subject of study by the Galileo project. According to Cao, there are ramifications for panspermia and the continuing discussion on the beginnings of life on Earth if these extraterrestrials are indeed detected. We can simulate the number density and mass density of objects in the interstellar medium using Oumuamua's physical parameters, especially its mass, size, spherical radius, and implied interstellar medium number density. This makes it a unique data point for panspermia models. Using these models, we can make educated guesses about the mass flux and flux density of interstellar objects, and we can use these estimates to roughly calculate the total number of objects that collided with Earth during the Z.8 billion year period, the theoretical window between when the planet formed and when life first appeared on Earth. In order to determine the plausibility of panspermia, it is crucial to know the total number of collision events on Earth during that 0.8 billion year period, since a higher probability for panspermia would be implied by a greater number of collision events with interstellar objects over that period. In short, the physical properties of the interstellar Oumuamua allow for the creation of mathematical models. A biological model that explains the smallest object size required to protect extremophiles from astrophysical events, such as supernovae, gamma-ray bursts, big asteroid impacts, passing stars, etc., was utilized by Cao and colleagues alongside mathematical models that account for the physics of panspermia. Cosmic rays disintegrate all interstellar objects except the largest before they reach another system, according to current research. These supplementary factors influence the likelihood of panspermia and the quantity of potentially impacting objects, unsterilized by astrophysical sources, that could hit Earth. In order to derive the minimum object size, we applied various models, for instance, the sphere packing method to give a rough estimate of an ejecta's distance to the nearest supernova progenitor, using Orion A, a dense star cluster, as our model, the gamma radiation that reaches that ejecta, and the attenuation coefficient, how much radiation the ejecta absorbs, based on the most probable chemical composition of ejecta, water ice. The number of ejecta that hit Earth before life originated was estimated by the team using their combined physics and biological models. The earliest fossils discovered in Western Australia date back to the Archean Eon, which means that life as we know it began around that time, about 3,500,000 years ago. They concluded that the maximum probability that panspermia sparked life on Earth is on the order of magnitude of 0.001%, although this probability appears low under the most optimistic conditions. Furthermore, we limited our study to the initial 0.8 billion years of Earth's history before the first fossilized signs of life were discovered. However, considering that planets can be habitable at any stage of their lifetime and can continue to support life for up to 5 to 10 billion years, we increased our estimate for the total number of habitable worlds in our galaxy that are home to life by 1 order of magnitude. Based on this, Cao and colleagues arrived at a final count of approximately 105 habitable planets in our galaxy that could support life. However, these counts are derived from the most optimistic predictions of planetary habitability, which means that all rocky planets of Earth's size that are in habitable zones can support life, with thick atmospheres, magnetic fields, liquid water on their surfaces, and all life-bearing ejecta that make it into our atmosphere can deposit microbes on the surface. Based on what Cao said, their results don't prove panspermia or put an end to the debate about where life came from on Earth. However, they do put constraints on the idea that objects like Oumuamua could have brought life here. Regardless, astrobiology is becoming a very diverse field, and these results will certainly have far-reaching implications for it. Astronomers are eager to get a better look at future guests because of Oumuamua's mysterious nature and the knowledge interstellar objects could offer about faraway star systems. There have been various suggestions for interceptor spacecraft that could track future interstellar objects, study them, and even return samples, such as the European Space Agency's Comet Interceptor. In a recent publication from the Southwest Research Institute, Alan Stern and colleagues examined potential ideas and proposed an IOE, or Interstellar Object Explorer, mission. Since Oumuamua buzzed our system, scientists have placed a high importance on interstellar objects. We could learn a lot about the development of other stars and planets without actually sending missions there if we could get samples and study them up close. Our understanding of planetesimal formation models has been greatly advanced, our ground-based observations have been better contextualized, and our knowledge of small bodies in our solar system has been greatly improved through close encounters with these objects. Similarly, a close flyby of an interstellar object is expected to be just as transformative, and it will be the next logical step in exploring the early history of both our solar system and exoplanetary systems. In addition, surveys of the population of interstellar objects have shown that approximately 7 cruise through our solar system each year, while other studies have shown that some are periodically captured and remain in our system. As next-generation instruments become operational, scientists expect a significant uptick in the rate of discovery of interstellar objects in the 2020s and 2030s, including the Vera C. Rubin Observatory in Chile, which is currently under construction and is expected to gather its first light in January 2025. In its first 10 years of operation, the Legacy Survey of Space and Time, the observatory is expected to collect data on over 5 million objects in the asteroid belt, 300,000 Jupiter Trojans, 100,000 near-Earth objects, and over 40,000 objects in the Kuiper belt. During this study, Stern and colleagues assumed that any interstellar objects within a distance of approximately twice the distance between Earth and the Sun would be bright enough to be detectable by the survey. The proposed IOE would have 2 primary scientific goals. First, to determine the composition of the interstellar object to provide insights into its origin and evolution. Second, to study the interstellar object's host solar system in its early stages, which would yield information similar to that which the New Horizons mission found about the Kuiper Belt object Arrokoth, or which the ESA Rosetta mission found in Comet 67P Churyumov-Gerasimenko, which is an important step in understanding the interstellar object's background. Secondly, the IOE would ascertain or limit the composition, origins, and nature of the interstellar object coma activity, as well as the processes that cause it. Usually, coma activity is caused by ice sublimating as objects approach a star, which releases dust grains and refractory organic molecules from the nucleus. Past observations have demonstrated that comet activity is influenced by solar heating and the comet's actual physical properties. By studying the coma of an interstellar object and its spatial distribution, we can learn more about its main components, the processes that cause it to be active, and how it formed. We can also learn more about the protoplanetary formation disk, where the object and similar planetesimals were formed, by comparing the physical properties of the ices and refractories in the coma and on the surface, such as their chemical composition, size distribution, and type of mixing. Secondly, the spacecraft design is constrained by the transient properties of interstellar objects, which, as shown by Oumuamua and Borisov, are expected to go undetected until they approach the inner edge of the main asteroid belt. Moreover, their hyperbolic trajectories indicate that they will most likely pass close to our Sun and become unreachable soon after their detection. Lastly, the intercept mission positioning directly impacts the spacecraft's capability to deploy and reach the target, interstellar object. A storage orbit at the Earth-Moon L1 Lagrange point, halfway between the Moon and Earth, was chosen for the study by Stern and colleagues for a number of reasons. One of these is that a spacecraft in such an orbit will have to generate very little thrust to reach escape velocity, directing the majority of its available acceleration towards its intercept trajectory. Additionally, a storage orbit reduces the amount of propellant required and the time needed to get underway, and permits a rapid gravitational assist from a near-Earth flyby. Interstellar object studies are a young, but rapidly expanding area of astronomical research that includes next-generation observatories and proposed intercept missions. Similar ideas have been put forward since the discovery of Oumuamua and Tuai Borisov, including Project Lyra, an initiative by the Institute for Interstellar Studies. Although such a mission might not materialize for a while, research like this will guide the next stage of development, which is the actual design and testing of mission concepts. Further research is required before this can take place, but Stern and colleagues stress that their work is a crucial initial step. Does anyone have any plans to negotiate with a society from another planet? So let's pretend we find an incoming interstellar object that astronomers first dismiss as a mere natural intruder, such as Oumuamua or Comet Borisov. We're warming up to the idea of visitors from other parts of the galaxy, though they've been inanimate so far. What if, however, we discover that this visitor isn't acting normally? What if it moves in an unusual way or acts on purpose? What if it settles into a stable orbit? What if, upon further investigation, we realize that it's actually a probe that was deliberately sent to us? What if it can communicate with us? Humanity finds itself in a whole new predicament, as if transported into a science fiction novel. How can we proceed? We don't know for sure if this will be the last first contact, but it's possible. If not for our species now, then maybe in a distant future when we have one. We can't completely dismiss this possibility, and much deliberation has been devoted to the question of how we should react. Some have proposed arming ourselves or enhancing our defensive capabilities, while others have proposed formally establishing diplomatic relations with extraterrestrial intelligence. John Gertz, who is not a working scientist, is the author of a new paper titled simply Interstellar Diplomacy. Contact with extraterrestrial intelligence is possible at this very moment. However, no international preparations have been made for what would happen after the first detection, a fitting term given the magnitude of the upheaval that would ensue if extraterrestrial intelligences were to make contact with Earth. Gertz argues that we must immediately establish a diplomatic strategy outlining our respective roles and responses. Our technological effort has never been greater, according to Gertz, and the search for extraterrestrial intelligence is leading the charge in detecting extraterrestrial intelligences. Gertz notes that SETI is so well funded that we may be entering its golden age. He mentions Yuri Milner's support for SETI, including his $100 million 10-year commitment from a few years ago. However, there are limitations to SETI, such as the fact that it can only observe a single star for a limited time, and that signals must be sent and received within that short window. Many different schools of thought have debated the merits of SETI, with Gertz stating that a more advanced civilization would probably send out targeted probes instead of sending messages to planets. In that scenario, a highly developed extraterrestrial culture would have assimilated our languages and other characteristics in preparation for contact, which could take the form of artificial intelligence capable of real-time communication with Earth, bypassing the need for an extended interstellar delay required for contact with its creator. It doesn't matter if first contact is a probe entering our solar system or a signal from another civilization. The consensus is that we must respond swiftly, especially if the signal is very far away. For instance, if the signal is 1,000 light-years away, then even if we reply instantly, it will be 2,000 years before the extraterrestrial intelligence sends its signal and receives our response. Will they even be paying attention by then? These questions are not new. Many thinkers have pondered these issues. But what if we're thrust into making a decision quickly? What if one of Earth's nations decides to respond on its own, either to a distant signal or to a visiting probe? As matters stand now, any one country might make the decision to signal by itself and thereby encumber all humankind and its future generations, writes Gertz. A wide range of possible reactions will be raised in the event that a probe was to visit us. Some will seek to kill it, some to capture it, some to regard it as an envoy, and, alas, others will be totally irrational and begin to worship it or something equally ridiculous. There are a lot of things that could happen with the probe, Some of them are unlikely, but it could serve as a Trojan horse, telling us what we want to hear and tricking us into complacency while its builder plots evil and sends a fleet our way. However, according to Gertz, regardless of the type of first encounter, humanity will need to organize itself like never before, and we need an international treaty to govern our response. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.